Most essential learning competency for Quarter 1, Week 1. Illustrates well-defined sets, subsets, universal sets, null set, cardinality of sets, union and intersection of sets, and the difference of two sets.
Hi, I'm Seth, and I am a grade 7 student. What do you miss about the opening of classes? Is it your friends, your teachers, or your new school supplies? Me? I miss wearing my cute little bag. This is where I keep my favorite things. Oops, they are plenty. Oh no, I'm so clumsy. Can you help me? How can we help Seth? First, let us observe the objects and their characteristics. Can you make a group out of these objects? How many groups were you able to make? Is it 3? The chocolate, the sandwich, and the apple go together. The pen, the notebook, and the ruler go together. The comb, the wipes, and the alcohol go together. We were able to make 3 groups. What do you think is the name of the first group? Do they have the same characteristics? Yes, these are her favorite snacks. What about the second group? Do they have the same characteristics? Yes, these are her school supplies. And the third group, do they have the same characteristics? These objects belong to her personal hygiene kit. Thanks for helping me. From what we did earlier, we realized that we can group objects based on their common characteristics. These groups can also be called sets. A set is a well-defined group of objects called elements that share a common characteristic. I will show to you some examples. Number 1, the set of letters in the word Philippines. Number 2, the set of beautiful girls. Number 3, the set of odd numbers. And number 4, the set of delicious fruits. Will you please observe the given examples? From the given definition earlier, it is mentioned that a set is a well-defined group of objects. Let us now identify which among the given examples is a well-defined set and which is not. Let us start with the first example, the set of letters in the word Philippines. The letters in the word Philippines are P, H, I, L, N, E, and S. If we can provide all the elements or the members of the given set, then it is a well-defined set. Let's proceed to example number 2, the set of beautiful girls. Although we can provide the names of beautiful girls, our answers vary from one person to another. Therefore, the set of beautiful girls is not a well-defined set. Can you now answer number 3 and number 4? Number 3, the set of odd numbers. Is it a well-defined set or not? Yes, it is a well-defined set. Number 4, the set of delicious fruits. Is it a well-defined set or not? It is not a well-defined set. Good job! Cool! Set sounds like my name. I want to learn more about sets. As we have said, the set of the letters in the word Philippines is a well-defined set. Therefore, we can list down all the members of this set. The objects in the set are called its elements. In this example, there are 7 elements. Set notation uses curly braces to enclose the elements and uses comma to separate the elements. Although the letters in the word Philippines are 11, we just listed 7 letters because the same element cannot be included in the set more than once. Uppercase letter is used to name the set. Here, U is the name of the set. And lowercase letters will be used to refer to any element of a set. When the elements of the set are listed, it is called roster notation. But there are times when it is not practical to list all the elements of a set. Take a look at this example. The set of all positive integers. We know that it is impossible to write all the elements of this set. If a set contains many elements, we often use 3 dots called ellipses. Or it is better to describe the set. This is called set builder notation. This can be read as A is the set of elements X such that X is a positive integer. Wow, sets are so cool! I want to learn more about sets. Let us now try to study the definition of the universal set. The universal set is the set that contains all objects under consideration. Can you help me form the universal set? Number 1, set U contains the days of the week. We know that there are 7 days in a week. So our set U should have 7 elements. Let us start listing down the elements. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. This time, we were able to complete the 7 days of the week. And we can say that this set is now a universal set. Now, it's your turn. Can you help me form the universal set that contains the letters of the word red? Did you say the letters R, E, and D? Yes, that's now the universal set because R, E, and D are the letters of the word red. So, we can now say that the universal set must contain all objects under consideration. That's it. The number of elements in a set is the cardinality of that set. In this example, the number of elements is 7. So, the cardinality of this set is 7. In our second example, the number of elements is 3. Therefore, the cardinality of this set is 3. Now, let us consider the following sets. Set A, containing the element 1. Set B, containing the elements 1, 2, and 3. What can you say about the relationship between these sets? Observe the elements of set A and set B. As you can see, the elements of set A is also in B. We can say that A is a subset of B. A Venn diagram for the relationship between these sets is shown to the right. Another way to define a subset is A is a subset of B if every element of A is contained in B. Now, let us try to complete all the possible subsets of set B. Here are the possible subsets of set B. the subsets with one element, the subsets with two elements, and the subset with three elements. If we will count all the subsets we made, there are 1, 2, 3, 4, 5, 6, 7. 7 subsets. But there is a formula that we can use to solve the number of subsets that can be formed out of the given set. It is 2 raised to n, where n stands for the number of elements in a given set. In this case, there are 3 elements, so 2 will be raised to 3. 2 raised to the third power is equal to 2 times 2 times 2, which is equal to 8. If there are 8 possible subsets for every 3 elements, then we are missing one subset, and that is the null set or empty set. Remember that the null set is a subset of every set. This makes our subsets equal to 8. Let's try another example. Try and fail, but do not fail to try. List all the subsets of the set C with elements 1, 2, 3, and 4. How many subsets do you think are there? If we will examine set C, we can say that there are 4 elements. Using this formula, we will substitute 4 to n, which is now equal to 2 raised to 4. 2 times 2 times 2 times 2 is equal to 16. So, we must be able to form 16 subsets. Let us start with the subset with no element, 1 element, 2 elements, 3 elements, and 4 elements. Here are some tips to remember when creating the subsets of a given set. The elements of the subsets must be found in set C. If possible, write the elements in order. Avoid writing equal sets. For example, 1, 2, and 2, 1 is just the same. Since we know that there are 16 subsets, then you may try to write or list down all the subsets of set C. Did you get the same? Good job! Just like numbers, sets have operations too. Let us learn about these one by one. What comes into your mind when you hear the word union? Did you say unite, combine, join? These words are quite related to union. Let us observe this example. Set A with elements 2, 4, 5, and 6. Set B with elements 4, 6, 7, and 8. Taking every element of both sets A and B without repeating any element, we will get a new set with elements 2, 4, 5, 6, 7, and 8. This new set contains all the elements of set A and all the elements of set B with no repetition. We can name this set as union of set A and set B. We will use this symbol. The union of two given sets is the smallest set which contains all the elements of both sets. Let us try to find the union of two sets one more time. Set C with elements 1, 3, 5, and 7, and set B with elements 3, 7, 8, and 9. Taking the elements of both sets without repetition, we will get 1, 3, 5, 7, 8, and 9. This is now the union of set C and D. This time, let us discuss the next operation on sets, the intersection of sets. Perhaps your idea of intersection is the spot where two lines cross. In here, intersection of two given sets is the largest set which contains all the elements that are common to both sets. Example, set X, which contains A, E, I, O, and U. Set Y, which contains C, A, T. Examine the elements of the two sets and tell me the common element of set X and Y. In this example, the only common element is A. This set is now called the intersection of set X and Y. We will use this symbol for intersection of sets. The keyword here is just find the common. This time, it's your turn to try. Can you give me the intersection of set P and Q? Set P consists of the letters B, A, T. And set Q consists of the letters B, A, T, and H. What is the intersection of set P and Q? The common elements are B, A, and T. Very good. And now, let us have the third operation, the difference of sets. Example, set J with the elements 2, 3, and 4. Set K with the elements 4, 5, and 6. To find the difference of these two sets, we will write all of the elements of J and then take away every element of J that is also an element of K. Since J shares the element 4, this gives us the set difference with the elements 2 and 3. So, in other words, J minus K means elements of J which are not the elements of K. Do you want to try to solve the three set operations? Come on, let's do it together. Alone, we can do so little. Together, we can do so much. Oops! We are asked to find the union of set C and D. Do you still remember how to do it? The answer contains the letters B, E, A, R, and C. As you can see, we just take all the elements of set C and D with no repetition. Great! We already formed the union of set C and D. What about the intersection of set C and D? Do you still remember the keyword? It starts with letter C. Common. Common element. What are the common elements of set C and D? These are the letters E, A, and R. That's the intersection of set C and D. We're almost done. We'll just now find the difference of set C and D. All we have to do is just list down the elements of C and take away every element of C that is also an element of D. So, the set difference of C and D is the element B. Now, we solved the three set operations: the union, the intersection, and the difference of sets. Let's wrap it up. Can you still remember the important terms we learned earlier? Grab a pen and paper and let us list the words one by one. How many words were you able to write? Me? I got 15. Let us go over these words quickly, one by one. The three set operations we discussed are the union, intersection, and difference of sets. The objects that belong to a set are called elements. A blank is a well-defined group of objects. Set is the set that contains all objects under consideration. Universal set. It is also called an empty set. Null set. It is used to separate the elements of a set. Comma. Blank will be used to name sets, and blank will be used to refer to any element of a set. Uppercase letters will be used to name sets, and lowercase letters will be used to refer to any element of a set. If all elements of F are also elements of A, then set F is a subset of A. It is the number of elements contained in a set. Cardinality of a set. It is used to denote a list of elements in the set. Braces. In this method, a set is described by listing the elements. Roster method. Lastly, in this method, a condition is used to decide whether an object can belong to the set.
Set builder notation.
Come on, let's check what we have learned today. Given set A with the elements B, I, O, D, E, G, R, A, D, A, B, L, E. Which of the following is incorrect? A. It uses capital letter to name set. B. It does not list the object once. C. It uses braces. D. It uses commas. Correct answer is letter B. It does not list the object once. Number 2. Which of the following is the set of odd numbers between 0 and 10? Correct answer is letter C. Number 3. It is used to denote a set. A. Universal set. B. Curly braces. C. Comma. D. Capital letter. Correct answer is letter D, capital letter. Number 4. Which of the following is a well-defined set? A. the set of young teachers. B, the set of months containing 31 days. C, the set of sweet foods. D, the set of famous YouTubers. Correct answer is the set of months containing 31 days. Number 5. Which of the following is not a well-defined set? A, the set of letters in the English alphabet. B, the set of all positive even numbers less than or equal to 10. C, the set of letters in the word Australia. D, the set of female students in a class. Correct answer is letter D, the set of female students in a class. Number 6. What is the cardinality of the set with the elements Coke, Royal, and Sprite? A, 3, B, 1, C, 4, and D, 0. Correct answer is letter A, 3. Number 7. Which of the following is false about set A with elements A, E, I, O, U? A, set A has 5 subsets. B, the cardinality of set A is 5. C, set A consists of the vowels in the English alphabet. And letter D, set A has 5 elements. Correct answer is letter A. Set A has 5 subsets. Number 8. What is the union of set A and B? Correct answer is Letter B. Number 9. What is the intersection of set C and D? Correct answer is letter D. Empty set or null set. Number 10. Find the difference of the two sets. Correct answer is letter C. How happy are you with your performance today? Are you feeling fantastic? Really good? Okay? Not very good? Awful. You may watch the video again or ask your teacher for your questions about the lesson for today. Whatever it is that you're feeling, never give up. Happy learning!